Hello students, I am coming with a derivation question, that is 2024 paper code 5511 question number 23B, 3 mark question, okay, derivation. What is a Wheatstone Bridge? Obtain the necessary conditions under which the Wheatstone Bridge is balanced. There is a 1 mark question for explaining what is a Wheatstone Bridge, and the remaining 2 mark for deriving the expression for unknown resistance. You know that this is exactly linked with the meter bridge. I will explain the derivation in step by step. Okay. Now, what is a Wheatstone Bridge? You answer that first. I put the text here. The time being, when you read the text, I just mark the points, Wheatstone Bridge. Okay. It is an electrical arrangement, right? With the 4 resistors are there, and 2 ends of the network bridge connected with the power supply is there, and the other 2 corners connected with the galvanometer is there. So you can use any label here, ABCD or PQRS or whatever you like. Resistance also like this one. You can use R1, R2, R3, R4 if you like, or PQRS. Let me go with the PQRS. And now there are 4 resistors in front of me, P, Q, R, S, connected in the form of a bridge. Okay. And the junctions I labeled like ABCD. You can see the ABCD here. And between the point B and D, a power supply is connected. So let me draw that one. Power supply is connected with the cell to D. So between B and D, power supply connected. You can see, right? Now the next one also, that is the current flowing through the circuit. That is, the main current is I. Okay, that current will split later. At the point B, it will be split as IP and IS. You can. Now we have to connect one galvanometer between the points A and C. After labeling this, I will do that one. Along the P resistor IP, along the S resistor IS. Okay. Then connect the diode. Connect the galvanometer now between point A and C. Connection made. That's all only. You can do the labeling for current also. Through galvanometer, we can say IG is the current. And at the junction A, you know that IP is coming, and that is split into 2 pieces, right? One part flows through the galvanometer, that is IG. Other part flows through the resistance Q. So we can write like IQ. We can write. Later I will write, okay? And through R also, IR will come. And the direction of the current also I marked here. Then always whenever you have a drawing, just write one statement about that drawing. That make a connection between your drawing and the derivation or the numerical you are going to do. So here we can write, consider 4 resistors P, Q, R, S connected as shown in the diagram or as shown in the figure, you can write. Okay, done. Now, how to go about this one? Little bit lengthy, but you can skip the steps once you mastered the step, okay? You have to apply here Kirchhoff rules. Before that, we have to decide one unknown resistance. Here, I decided P is my unknown resistance. Okay, P is my unknown resistance. So, there you can do the final expression, you can come to P is equal to. Okay. Let me write this again, because what I wrote before got deleted. So I wrote again the same statement. Consider 4 resistors PQRS connected as shown in the figure. And here P is the unknown resistance. And how to apply the Kirchhoff rules. Always remember these 2 tips. Just to remember. So that if you go with that one, you will get the answer. The first tip is apply Kirchhoff voltage rule. First we can do the current rule. Apply Kirchhoff junction rule. You know the junction rule also known as the current rule, right? Junction rule at points up and down. Memorize like that one, so that even variable got wrong, no problem. At the points up and down. So read that one is A and C. C is the downside point, yeah. While writing, I wrote there A and B. Okay. So read that one is A and C. Up point, that is A, down point C. Second one is the voltage rule application. The half rule we are considering, and full loop we are half loop, full loop. Here half loop is, see from the point B, B BACB. Apply voltage rule there. I did a direction of current marking. Then second one BADCB. Okay. So voltage rule apply in first half loop, then the full loop. Now we start now. First we start with the current rule, that is the junction rule. Okay. Apply junction rule at top point. What is the top point label? B, right? We marked A, it is A, sorry, A. So apply junction rule at A. You know that junction rule is sum of the current entering is equal to sum of the current leaving. If no more than one term, no need to do sum. So here the current entering is IP. So IP is equal to the current leaving is IG and IQ. You can see in the diagram at the point A, direction away, two other direction in, towards, one is there. So first equation labeled. IP is equal to IG plus IQ. Second equation, downside point. Downside actually two current coming, right, and one current leaving. If you look into diagram, you will see that one. IR is current leaving, IS plus IG is the current coming to that point. You can see now. Now done. That is equation number 2. Now go to the voltage rule application. First half loop. You know that half loop is BACA, I think. Yeah, BACA. Yeah. So what is voltage rule? Voltage rule is sum of the EMF in the circuit is equal to sum of the potential drop across each resistor. So here the potential drop across P is IPRP plus potential drop across G is galvanometer is IGG and minus I put. Why minus I put? I will show in the diagram. Direction of the current flowing the circuit is opposite to the clockwise direction what we assumed. Can you see that? See, IS is negative. That's why ISS is equal to 0. Similarly, apply the voltage rule in the big loop. So big loop you can see the BADCB. BADCB. So start EMF here also. No EMF in the circuit in the loop. So EMF will be 0. Okay, EMF not there. So voltage drop across IP is IPP because V is equal to IR, that one. Plus IQ into Q. IQ is suffix Q. Okay. Minus IR into R because that is in opposite direction, refer the diagram, and minus IS into S is equal to 0. So two resistor direction of current through the resistor R and S are opposite to clockwise direction. So that's why it is negative taken. Okay, it's equal to 0. And when galvanometer shows 0 deflection, I think you completed meter bridge experiment, right? So galvanometer 0 deflection we are taking. Why? We know because there is no current flowing at that point. So when galvanometer shows 0 deflection, meaning is IG is equal to 0, no current flowing through that one. So substitute this value in equation number 1, 2, 3. In all these equation 1, 2, 3, IG exists. We did not write equation number 4 here. Equation is there. I forgot to number it. But there is no IG term. So not substituting right now. So start substituting. While substituting, okay, take to remove one of the variable, then only the equation will work. So you understood that we have option to replace variables now. So IP, IG plus IR is equal to, IG is equal to 0, right? IG is equal to 0 meaning is IP is equal to IQ. Similarly, when IG is equal to 0 in equation number 2, IR is equal to IS plus 0. I rounded here, so IR is equal to IS only. That is equation number 6 now. Now substituting that one, equation number 4 I marked now. Equation number 3 also we want to substitute the value of IG is equal to 0. So IPP, look into equation number 3 and follow the writing, plus IGG. This IGG will be 0 in next step. Minus IS into S is equal to IS into S. Okay, I will write now is equal to 0. See, IGG is 0. So what we can write is that area, just to do a transpose. So left side IP into P, that is IPP is equal to minus ISS it is. Okay, minus ISS. Take to right side, it is ISS, equation number 7. Almost finished, just a division required now. Okay, just a division. So before division, we did not do anything on. We should have an idea that which variable supposed to remove in the derivation. So here IP into P plus Equation number 7, okay. Then IP into P plus IP into Q, replacing now, okay. And IP into Q minus IS into R minus IS into S is equal to 0. So IP common now, IP into P plus Q minus IS into R plus S. Now IS is common in term 2, okay. Now it is easy. IP into P plus Q is equal to, take to right side the IS term, IS into R plus S. Now divide equation number 8 with 7. So LHS by LHS we do first. So IP into P plus Q divided by IP into P is equal to, then IS into R plus S divided by IS into S. Yeah, IS into S. Now simplify, cancel it, IP cancel, IS cancel. Now you know that LCM work, right? If the denominator is same, we do the addition of numerator. Do its reverse process now. P plus Q by P is equal to R plus S by S. That equal to actually P by P plus Q by P. You learned this one. Is equal to R by S plus S by S. P cancel, SS cancel, 1 will form. That one if you transfer to other side, 0 will happen. So what left now is only one thing's left. That is after that one, Q by P is equal to R by S. Look into the diagram and decide which is unknown variable. Because of P is unknown variable, take a reciprocal now. So P by Q is equal to S by R. Then make P is the subject of the formula. That means P is equal to Q into S by R. Q into S by R. This is the equation for unknown resistance. So accurately you can measure the unknown resistance using Wheatstone bridge. Its practical application is meter bridge in the physics lab. How is this derivation? 3-mark question. Try not to lose any mark. Use all the steps. And if you need any derivation like this one, just post your request in the comment box. I will come with the solution. Okay, students. And if you enjoyed this video, please like the video and every day try to watch the video. Every day 7 p.m. GST I will post the video.